Hi everyone, so now we're going to be talking about line properties of triangles. In the last video we talked about angle properties, so these are just a couple more theorems, but now instead of talking about angles, we're talking about lines and the lengths of lines. So the first one we're going to talk about is called the mid-segment theorem of triangles. Basically what you need to understand is that a triangle can be cut in half. And we know that it's cut in half when it tells us that this length, like from A to D, is equal to this length from D to C. Same thing with, let me change the color. Over here, like E to B would be equal to C to E. And it has to show you that in order for this mid-segment theorem to work out. But if that does work out, then if this is X, then this is 2X. Basically, the bottom is twice the length of the middle. So there's the mid-segment theorem. Now let's talk about the next one down, the median theorem. The median theorem says that if I cut a triangle with a median, it makes it so that the length of one side is equal to the length of the other side. So in this case, BM is equal to MC. The median is different than the angle bisector, like what we talked about in the previous video. So the angle bisector cuts the angle in half, where the median cuts the side in half. And the last theorem that we're going to talk about is the centroid theorem. So the centroid theorem basically says that on these three lines that are cutting this triangle are called centroids. And in a centroid, we have that the way that I like to think about it is that the whole length, so like if I'm just going to look at from A to X, this line, that whole length is going to be 3 parts. And then from A to G is 2 parts. And from G to X is 1 part. And it's kind of confusing right now, but I'll show you how to work them out in the examples. So let's just get started with the examples. The first example says to find X, and this is going to use that mid-segment theorem that we were talking about, which, because we know that it's the mid-segment theorem, we know that the line in the middle is equal to twice the line on the end. So the way that I can write it is I can say something like line SR, or I'm sorry, so 2 times the line SR has to be equal to line CA. And then I'm going to replace the SR and the CA with what I know what it is. So I'm going to say 2 times 2x plus 23 is equal to x plus 16. And now I just solve it like a normal equation. So I'm going to distribute the 2 first. So I'd get 4x plus 46 is equal to x plus 16. I'm going to get the x's on the same side by subtracting the x over. The x's cancel out over here. I'm just left with 16. And then I get 3x plus 46 over here. Now I'm going to subtract 46 because I want to get the x by itself. 46 is cancel over here. And I end up with negative 30 over here. Then I divide each side by 3. And I end up with x is equal to negative 10, which is my answer. All right. And that one was using the median theorem, which says that the small length is equal to twice the bigger length. Let me just make sure that I wrote that down correctly. Yeah. Okay. Let's look at the second example now. The second example says find X if HG, or I'm sorry, if HZ, how did I write that? That is super funny. This should be a Z. I'm sorry about that, guys. So find X if HZ is X plus 7. And hx is 2x plus 2. So I'm going to write that down right here. So we know this is x plus 7, and then we know this is 2x plus 2. So this is using the median theorem, and the median theorem says that the median cuts the line in half, which means that these two sides are equal to each other. So I can write this equation that says 2x plus 2 is equal to x plus 7. And now I just solve it for x. So I'm going to subtract x on each side to get the x's together. 2x minus x just gives me 1x, which I can write as just x. Then I'm going to subtract 2 from each side. And I end up with x is equal to 5. And that one was way easy because those equations were quite simple. All right, these last two examples talk about the centroid theorem, which is the one that I was trying to explain to you earlier in this video, and I think it'll be easier to understand with the examples. So example number 3 says, find FR if RC is equal to 5. So I know that from R to C, this length right here is equal to 5. And the goal is to find this line. So if you look on your cheat sheet or your key term sheet, it tells you that if I compare this, like the short portion to the longer portion, that's like saying 1/2. So the short portion is like my 1 part, and then my long portion or my longer portion is my 2 parts. And so I'm going to compare that to what I kind of know what the fraction is. So I know the green part of it is 5, or the short portion of it is 5, and I want to find the blue portion, which is the question mark. And I can set these two things equal to each other because we know it has to compare to that ratio of 1/2. And so when we compare two fractions like this, or set two fractions equal to each other, we cross multiply, which means I'm going to get 1 times my question mark is equal to 2 times 5. So now 1 times question mark is just question mark is equal to 2 times 5, which is 10. So my answer is 10. All right, now let's look at the fourth example. So it says find x if CH is equal to x minus 1 and CQ is equal to x plus 4. So once again, we have CH, which is kind of like the way that I like the longer part, or the 2 parts portion. And we know that is x minus 1. And then we also have that CQ, which is the entire line, is equal to x plus 4. Now, once again, we're going to compare it. And if you look at your cheat sheet again, if you compare the longer side to the entire side, the longer side is like your 2 parts. And then the whole portion is like your 3 parts. And so I'm going to compare the longer side, which is 2 parts, to the whole portion, which is 3 parts. So I'm going to have x minus 1 for my 2 parts over x plus 4 for my 3 parts. And now once again, when I have two fractions that are set equal to each other, I can cross multiply. So I'd get 2 times x plus 4 is equal to 3 times x minus 1. And then I solve that for x. So I'm going to distribute the 2 first, and I'd get 2x plus 8. Distribute the 3. I get 3x minus 3. Now I want to get the x's on the same side, so I'm going to subtract 2x from each side. It doesn't matter which side the x's end up on, and I always try and get the x's to stay positive, so I always move the smaller x, but it doesn't really matter. So 3x minus 2x gives me 1x, which I can just write as x. Then I can add 3 to each side to get the x by itself. We get 11 is equal to x, which is our answer. Okay, and this is how we deal with line properties of triangles.